Hi, I'm Ben Schiffer.
Hi, I'm Daniel Bousquet.
During our time in the Immersive Scholars Program, we worked in the Pearl Lab with our advisor, Professor Reza Ahmadzadeh, on classification of demonstrations for robotic learning. Pearl is the Persistent Autonomy in Robot Learning Laboratory. Research here is focused on many facets of robotics relating to autonomy and human interaction.
We implement an approach called LFD, or Learning from Demonstration. This allows a human operator to demonstrate to a robot ways to complete a task. Professor Ahmadzadeh designed VSL, or Visuospatial Learning, during his own research as one method to accomplish this. It allows the robot to plan out a task step by step based on the position of static features in its environment.
Our contribution was to help refine this method by implementing image recognition and a new method to classify past demonstrations. We used several filters to allow the robot to better recognize objects and obstacles in its environment. We examined the role object detection can have in labeling of demonstrations by using AR markers, scale invariant feature transform, color filtering, and Kalman filters.
Here we show a human operator demonstrating a method to a robot for completing a task. We studied a situation in which the robot based its solutions on several of these demonstrations, each of which might fail if an obstacle is introduced into the environment. Current algorithms usually rely on a human operator to rank or label demonstrations. It is not always efficient to complete the task by hand, especially in the case of an inexperienced user. As a solution to this, we programmed the robot to model past demonstrations and predict whether or not each would succeed or fail. Hundreds of recorded locations for the end of the manipulator are graphed to show the trajectory.
We recorded 4 successful demonstrations in which the robot followed a curved path to reach a goal. These represented our user data. For convenience, we guided the robot by hand. We then moved an obstacle into the path of several of these demonstrations. The first task completed by the robot was recognizing the obstacle. In the final experiment, AR filters and feature detection were used. A bounding box was then placed around the object. The second task was homography, in which the pixel coordinates of the bounding box, as seen from the camera, were transformed into a usable location and dimensions for the manipulator.
The robot then has enough data to model the obstacle as it would interact with the demonstrations. If any of the points in a demonstration pass within the obstacle, that demonstration is labeled a failure. Classified demonstrations are used in a trajectory learning algorithm which generates a new trajectory shown here in black. The new trajectory avoids failure demonstrations while closely following successes.
Shown here is a production of the final trajectory by the manipulator. We found that we could reliably label demonstrations and use this information to inform reproductions of the same task in new environments, as well as dynamic environments. The robot reevaluated past knowledge for each new environment, and generated a new trajectory following the example of successful demonstrations and avoiding failed ones.
Our approach occasionally failed because the image processing had inaccuracies. Because only the end effector's trajectory was determined, other joints could freely pathfind into failure states. To improve on our research, we would make it more robust. We would like to implement failure recovery and reclassify demonstrations quickly based on feel in case of collisions.
Our approach is limited because the robot requires many demonstrations to find reliable solutions. However, in cases where this is possible, these findings have much wider applications than manipulators. Our research has contributed to the subject of failure recognition, as well as failure-based pathfinding. It will allow robots to better understand simple tasks taught through human interaction, and give them the tools to adapt their knowledge to new environments.